That is unit of one concept of measurement. So this is the syllabus for unit number 1, concept of measurement. Next, what is called metrology? So one of the main things of checking the quality of the product. So it is very important. So metrology in every industries we can focus on the quality. So quality is a main purpose of satisfy the customers. That is why we can introduce the metrology. So metrology is a name given to science of pure measurement. That is called metrology. What is called engineering metrology? The engineering metrology is restricted to measurements of length and the angle. You can measure any length of the component and the angle can be measured by use of various instruments in engineering metrology. That is the purpose of metrology. So metrology is the science of pure measurement. It's restricted to measurements of length and angle. What is the definition of measurement? The measurement is defined as the process of evaluation of a dimensions or the process of comparison with the standard measuring instruments. We can using the different measuring instruments, we can measure the various measurements, compare with the standard value to do the what is the exact value of the equipment or tools. That is called measurement. So measurement is defined as the process of numerical evaluation of a dimension or the process of comparison with the standard measuring instruments. Why measure the things? That is the main measure things of the in the industries or checking the quality of the product. Mainly measure things based on the check the quality. What is the quality of the product? That is the main purpose of can measure the various things. And then check tolerance. Check tolerance means that some permissible value plus or minus 0.01 or 0.02 millimeter. That is a minimum, maximum 0.01 plus value minus 0.01 value. That is a check tolerance. Third one, allow statistical process. That means allows the maximum permissible value and a minimum permissible value that can be measured upper limit and lower limit. So maximum. For example, checking the length of the quantity, length of the component, 30 millimeters length. So maximum 30 plus or minus 0.1 plus or minus 30 minus 0.1. That is a permissible. That's called statistical process control. So quality cannot be measured in the product. And then what is the need of measurements? What is the purpose of to take the measurements, checking the value of the and the quality of the product? So based on this criteria, we can measure the various things. So establishing standard, interchangeability, customer satisfaction, validate the design, physical parameter into the meaningful number, two dimensions, evaluate the performance. These are the based on the criteria we can measure the various things like length and the angle of the given component or tools. These are the based on the needs we can measure the things. What are the different methods can be used for measure the various quantities? Like first one, direct method, indirect method of measurements, comparative method of measurements, coincidence method of measurements, contact method of measurements, reflection method, and the last one, complementary method. These are the different method of measurements to measure the things. We discuss one by one. That is the direct method. So one of the basic methods you can measure the value of the given component. For example, simple example, steel rule. For example, scales or steel rule can be measured the length of the component, or based on vernier caliper can measure the various measure for the length of the component and the diameter of the given component. So this is a measurement directly obtained by use of scales or by use of vernier caliper. We can measure the any length and the diameter of the or cross section of the any component. This method of measurement is called as direct method of measurement. Second one, indirect method of measurement. These are not use of the scale or any instrument. This can be directly applying the formulas to calculate the value of the given product. For example, obtained by measuring of other quantities like weight. Weight means what is weight? So length and the breadth and the height multiplied by the density, or weight equal to volume multiplied by the density of the given material. So when you measure the your single component, measure the length and breadth and the height of the given component, applying the formula can calculate the volume. So volume, what is the form of volume? length, breadth and height. So multiply the density. Density is vary from various metal to metal. For example, mild steel can have value of density. For example, cast iron, brass, bronze, gold. So each and every metal having the different value of density. So multiply the density to find out the weight. This is the indirect method of measurement, but taking the values. And then comparative method. Third one. It is compared with the other known values. That is how some instruments can measure the standard value. Can using the comparators to measure the thing, measure the value, compare with the standard value. So what is the difference? That is equal to error of measurements. That's why we calculate the error. So standard error equal to true value minus the measured value. This is a comparative method. Use of compare one of the comparator. There are different types of comparators are available. Mechanical comparators, electrical comparators. There are different comparators are available. We are using the mechanical comparator. Can measure the value compared to the standard value. This method is called as a comparative method of measurement. Coincident method of measurements. This measurements also used by vernier caliper and micrometer. So simple tools, vernier caliper and micrometer can use the measure the length and various cross section of the component. What is the use of vernier caliper? Vernier caliper used with there is a one measuring instrument. It's got the main scale and pitch scale. There is a least count for the vernier caliper. Maximum least count is 0.0 mm or 0.02 mm. So measure the length of the component. First can measure the main scale reading and then pitch scale reading. Pitch scale reading where the main scale and pitch scale coincidence at the some point of time. That value is called as a pitch scale value. The pitch scale value is multiplied by the least count and then getting the total value of the component. That is called as a coincidence method of measurements. And then third one, fundamental method. Measure the directly related to the definition of the quantity. That is a fundamental basic method. We can measure the quantity of the product. Third one, contact method. By use of various props or sensors or by use of manual or hand can touch the any surface of the component. Any deviations are from the surface can easily measure. That can be find out the error of measurements by use of the sensor or machine tip touch the surface. Machine tip on the prop, so flexible prop, they move up and downward. So whenever can apply the prop can change the measurements. That is a contact method. And our complementary method. This value of quantity to be measured is compared to the known value of the same quantity. So that is a some volumetric tube. So volumetric by the liquid displacement. So two bottle, so different set of readings, and then two bottles are filled with the water and apply some of the weight can be dipped into the water, can change the value. So compare the volume, compare the value between the two tube. That is called as a liquid displacement method, can calculate the volume. So measure the compare the known value. And then deflection method. This quality method is directly indicated by the deflection of the pointer. For example, pressure measurement. This is nowadays can using the for example go to the hospital or go to the some mechanical shop, can measure the tube tires or human pressure or cylinder pressure, can measure easily measure based on the pressure gauge. Varying the pressure gauge, applying the pressure in the dial can shows the readings depending upon the what is the pressure inside the tube or cylinder, what is the pressure of the human bodies. That is the difference of the point this measurement is a pressure measurement. Next topic is next topic discuss about the units and standards. What is the units? What is called units? What is called standards? There are different types of units. That is SI units. This is called fundamental units and derived units. What is the fundamental units? There is fundamental units. There is a change in the units depending upon the any change value. These are fundamental. For example, these are various physical quantity. So unit name. What is a symbol of that is units. For example, length. As in terms of length is meter. or millimeter or centimeter or etc. That is a length meter, and then mass is the kilogram or kg. Symbol is a kg. Time is a second, and then electric current is ampere. That symbol is A. Temperature is a Kelvin. That is a K. Amount of substance, that is a mole, mol, and unit density is a candle. This is a C. These are the fundamental units can be used in the measure the various things. And then derived units. Derived units, so apply the values into the formula to find out the one value. That is a derived units. For example, these are the various physical quantity. For example, area. Area, what is called area? Area is the length and the breadth. So it is equal to the square, or simply called as a square meter. So one component measure the length and measure the breadth. That is equal to value. That is area. Area equal to meter squared or a squared. For example, a is a area, a squared. So substitute the value, can get the one value, that is called area. Area in terms of meter. So this is the derived units. Can derive from the formulas. And then volume. Volume is the length and the breadth and the height, or simply called as a cubic meter. Volume, take the one component or component can measure the length and breadth and height. This is the volume of the given matter in terms of meter cube. Speed. Speed is a meter per second. For example, can go to the vehicle moving on certain speed. Lengths are the seconds. So this is speed of the meter. That's called meter per second. And the acceleration, there is a meter per second square. These are the acceleration. How to accelerate the all these things. And then weight and force. Weight is in terms of Newton. Force is also in terms of Newton. Pressure is a Pascal. Symbol is a PA. Energy or work is joule. That is called G. These are the various units, but from derived. Apply the values and formulas get the units. These are the fundamental derived units. Simply called as a SI units. And then supplementary units. These are the based on the measure the angle, plane angle, radian, that is simple RAD, solid angle, radian, SR. These are the some of these supplementary units can be used for to measure the various quantities. What are these standards? That is a very important. In every industries or every product to be manufactured, that is maintain this standard. That is a very important. To every organization or industries can getting the quality of the product based on the standards. So the standards can be classified as a different standard, international standard, primary standard, secondary standard, working standard. All the companies, all the organization or industries can meet the standards. That's why can accept the customers. Otherwise, it's a defectable product. So based on the standard, it's called international standards. Primary standards, secondary standards, working standards. What is called international standards? These are internationally accepted international organizations of legal metrology, Paris International Bureau of Weights, measures and serves as France. These are the different countries can follow the standards. Generally, organizations of in metrology, organization of legal metrology. Paris International Bureau of Weights and Measures Service also in France. In India, can you see the only for National Physical Laboratory. This is the address for contact to the physical laboratory. In India, this is the authorized sector, the government sector can authorize approve the this is a value without getting the acceptance from the National Physical Laboratory. Any quantity cannot be, any quality of the product cannot be accepted by the future. So that is only why, that's why only the National Physical Laboratory can approve the this is the standard of the particular product. That's why can meet the standards. So these are the different standards of the measured in metrology. And the measuring instruments. What are the instruments can measure the various component to checking the quality and checking the value to compare to the standard value. These are the very important measuring instruments can be used for measure the things. There is a first one deflection and the null type instruments. Second one analog and digital instruments, active and passive instruments, automatic and manually operated instruments, and conducting and non-conducting instruments, absolute and secondary instruments. Last one, intelligent instruments. These are the various instruments can be used for to measure the value. We discuss them one by one. What is called diffraction type and null type method of measurements. These are the generally normally can using the nowadays are using the all these places can measure the weight of the given quantity. That means physical effect generated by the measuring quantities equal opposing effect nullify the physical effect caused by the quantity. These are the different diffraction type can measure the various things. This is a diffraction pointer type. This is the way of reading. Can measure the any weight of the component. This is a graduated scale. Scale is a 5, 8, 10, 15. That is in terms of kg. So can measure the any component weight or any quantity of the component. For example, nowadays using the fruits can be based on the weight. So using the different null type instrument to measure the readings. Analog and digital instruments. These are physical variables of interest in the form of continuous stepless variations. Physical variables represented by the digital quantities. This is in terms of the digital. This is the first picture shown the in the every automobile vehicles, cars, two-wheelers, etc. This is about the miles per hour. Easily can measure the what is the speed of the car or speed of the buses or speed of the two-wheeler can in per unit second. So this is one of the measurement digitally, and this is a digital type can measure the speed of the instrument speed of the vehicle. This is analog and digital. This is the latest analog is the oldest version. This is the latest. Digitally can measure the speed of the vehicle. And there are active and passive instruments. The instruments are those that require some source of auxiliary power. The energy requirements of the instruments are being made entirely from the input signal. Some of the, for example, storage tank can fill the water, can apply the pressure, can change the value. That is change the value. That is called active and passive instrument. This instrument also requires some source of some internal power required for the measure the values. That is called active and passive instruments. Automatic and manually operated. This is also additional instrument can be measured based on the weight in terms of kg weight, in terms of kg. So manual operated and automatic operated. Manual operated requires the use of human. Automatic without use of human help can operate in the weight, can measure the any quantity of weight. This is a manual operated and automatic weight instrument. This is a digital, this is a manual. These are contacting and non-contacting instruments. The contact is the measuring medium. Measure the desired input even though they are not in close contact with the measuring medium. This is a one of the last 2 to 3 years. This is a very important tool to measure the temperature of the human body because of the pandemic situation. Can using the without touching the human body. So all the doctors or any humans can using the instruments to touching. For example, this is a temperature measurement. Easily contact with the body. Wait, so some of the 1 or 2 minutes kept in the body can measure the what is the temperature of the human. This is the digital one. This is the latest one. Without contacting the human or without touching the human, can measure the temperature of the body of the human. That is a very one of the major equipment using in the last 2 to 3 years for measure the temperature of the human body. This is called as a contacting and non-contacting instruments to measure the temperature. These are absolute and secondary instruments. This instrument given value of the electrical quantity in terms of absolute quantities. Reflection instrument can be read directly. So apply the load, apply or increasing the load can digitally changing the value of the current. Current in terms of is ampere. So for measuring the electrical quantities. intelligent instruments. These are the nowadays is the digital. These are microprocessor the measuring instruments. So all the accurate reading getting from the digital instrument, that is called intelligent instrument. This instrument is incorporated with the microprocessor. Can be using the any value, for example, pressure or speed, any value can be measured by the digital instrument. This instrument is called as a intelligent instrument. Measure the various readings by digital. And then what is the characteristics of measuring instrument? What is the purpose? What is the characteristics of measuring instruments? There are 4 characteristics of instrument. What is one? Sensitivity. Second one, readability. Third one, range of accuracy. Fourth one is the precision. So every measuring component can follow these 4: sensitivity, readability, range of accuracy, and precision. Yes. What is called sensitivity? The sensitivity is defined as the ratio of magnitude of response of output signal to the magnitude of the quantity being measured. So what is the ratio of output signal to input signal? That is called the sensitivity. So one component, every component, like for example transducer. For transducer, to the what is the input, what is the output? That is the ratio. That is called sensitivity. So sensitivity is defined as the ratio of magnitude of response output signal to magnitude of quantity being measured. That is input signal. Readability only. Readability is defined as the closeness. This scale of the analog instrument can be read. That is called readability. For example, temperature measurement. Measuring the thermometer is kept at the body 1 or 2 minutes. After that, can use of human eyes can measure the what is the temperature of the human bodies. That is called readability. Reading the various readings. What is that? Okay. So very important range of accuracy. What is called accuracy? That is the meaning of thinking of the metrology. Metrology means accuracy. So accuracy. So every component can be every component tools can be produced with accuracy. That is a very important. Without accuracy, we cannot be changed. We cannot be satisfied with the customer nowadays. So accuracy is very important. So what is called accuracy? The accuracy of a measuring system is defined as the closeness of the instrument output to the true value of the measured quantity. So you can take the various measuring instruments to measure the taking different set of readings. So compare the readings, which one is the closeness to the standard value? That is called accuracy. So otherwise, it is called as the error of measurement. So based on the accuracy, can easily find out this is the error. This is the errors of measurement. So error, what is called error? Error means measured value minus the standard value, that is equal to error. So accuracy means closeness to the measured value. And then precision. Precision defined as the ability of the instrument can reproduce a certain set of readings there given accuracy. This is called precision. Precision means takes different set of readings. Each readings can repeating the same value without changing the value. That is called precision. That is called reproduce the certain set of readings there given accuracy. So for example, 10 set of readings can be taken. Each value close to the corner. That is called precision. These sensitivities are changing the output and changing the input. That is equal to sensitivity. The sensitivity may be a linear or non-linear. So to draw the curve can be linear or non-linear. What is the value? And the readability is defined as the readings may be taken by the instrument. Readability difficulties may often occur due to the balance error when observer nothing in the question or balance in the calculator. For example, weight measurements, the observer without changing the position of the eyes, so can measure the things. For example, change the position and very difficult to getting the accurate readings. That is called readability. These are things I can measure the readings. Readability. What is the value in the volumetric tube? There are set of linear engraved scales, that is 50 and 60. What is the value? This is what I am. So what is the value? That is the readability. So very difficult to getting the accurate value. So what is the value? What is the value? That is a very difficult readability. So what is the accuracy? Accuracy means the action is measured values are given true value. So that is called closeness to the true value. The difference between measured value and true value is known as error. So one of the error of instrument is the measured value minus the true value. That is equal to error of measurement, accuracy, quality of the conformity. So only based on the what is the percentage of error obtained, you can based on the percentage error to differentiate the this is the accuracy of the quality, accuracy of the quality of the product. So based on the accuracy and confirmation of the quality to satisfy the customers. Example accuracy, what is the more accurate when we must book at the through the 17 meters, the 17 centimeters, 16 centimeters, 8 centimeters, 15 centimeters. This is a difference of 1 centimeter, and then 15 centimeter by 15. This is the accuracy value. First here, A is a not accurate value. Because of that, there is a 17 centimeter or 15 centimeter or 18 centimeter. Only 17 centimeter closeness to the one first rating is only for accuracy. Remaining three set of ratings are accuracy because of not closeness to the true value. Second one, B is a nearly closest to the this accuracy. This is precision means a set of readings repeating the same readings. Measurement depends on the instrument used to measure. What type of instrument can use for measure this? Take this set of readings. For example, how long take this book? Who is a more precise in measuring the same 17 centimeter book? This is a 17 centimeter, 16 centimeter, 18 centimeter, 15 centimeter. This is second one is a 15 centimeter, 15 centimeter. Only for 17 centimeter. This is a nearly 17. So these are the repeating the same set of readings 17, 16, 18, 15. So they are very close to the accuracy value. This is repeating the same values 15.5, 15 centimeter, 15.2 centimeter, 15 centimeter. That is a precise value. So they can have different set of 5 values can repeating the same values. This is a chart accuracy. First is accuracy. Second one is precise, but then not accuracy. There are two circles, outer circles and inner circles. Here, second picture is outer circle, inner circle. First picture, this is center point of contact. So all the arrows can meet the one point of contact. That is why I say there is accuracy. Second one is not accuracy, but precise. Precise means all the arrows are meet at one point, but not yet close to the true value. So first picture is called as high accuracy and high precision. Second one is the low accuracy and high precision. But because of that, not close to the true value. So high accuracy, high precision, and low accuracy. This is a way of differentiate between the high accuracy and high precision. How to differentiate the accuracy and precision of the given set of readings. The person with the bullseyes. The three targets, which three arrows is to shoot. First shoot. This is there are different three shoots are available. All the three shoots are connected to the same point. That is called as high accuracy and high precision. Second one is again two arrows. Three arrows are targeting the point, but not close to the true value. The yellow picture is a true exact picture, and then the arrow marks arrow not close to the true value, but three arrows are close to the true value. That is a precision and not accuracy. This one is not precise and not accuracy because three arrows are indifferent but not close to the true value. There is a difference between the accuracy and precision. How do they compare? Both accurate and precise. First one, because of that, all the three arrows connect the same point, same equal value. So that is what called as both accurate and precise. Second one, precise but accurate. Third one, neither accurate nor precise. Not because of that, there is a not equal set of readings, but not close to the original value. So there is a neither accurate nor precise. So not accurate and precise. So can you define accuracy as precise? This is a way of can define the accuracy and precise of the given instrument to measure the errors. Based on the error, can check the quality. What is called uncertainty? The word uncertainty casts doubt about the exact of the measurement results. So true value is plus or minus uncertainty. So uncertainty means that is a exact value. Uncertainty means that is a not a accurate value. So true value equal to estimated value plus or minus uncertainty. That is called plus or minus is called tolerance value. Plus or minus 1.0 nm, 0.0 plus 0.0 nm minus 0.0 nm. Otherwise, adding the estimate value, that is your true value. More than the uncertainty, more than the tolerance value, can reject the quantity. That is called uncertainty. Measurements are performed on the instruments, and no instrument can read infinite number of decimal places. So that is why can uncertainty means so not exactly take the same set of values. So it normally can approximately can measure the value. That's called uncertainty. So instrument below the greatest uncertainty is a measurement. These are the some of the measuring instruments. Very difficult to check the correlations of the value. This is uncertainty. That is reading the meter stick. This one of the uncertainty. For example, the centimeters glance scale. This is a long scale. By use of the human can use of scale to measure the component. First digit known as a 2. That is equal to 2 centimeter. What is called only 2 or 0.00. Second one, second digit so 0.07, 2.7. What is question mark? Third digit estimated between 0.05 to 0.08. Length reported 2.7 centimeter or 2.76 centimeter or 2.78 centimeter. These are the uncertainty values. It's vary from one person to another person. So in 2.77, only for known digit is 2 and 7 are the 100% uncertain. Remaining are uncertain. So that is measure the third value. Measure the estimate value to get the true value. Third digit is the uncertain value. Because of that, is a decimal point. Can 7. So there is no end. So infinite number of decimals. So only can take the certain value is 2.7 centimeter is the exact value. Last 0.7 is the not uncertain value because of the values are changing decimal places. So in reported length, all three digits 2.7 centimeter are significant, including the estimated one. All instrument systems are characterized by the system. Characteristics are system response. These are the two performance instruments. There are two basic characteristics of instrument: static character and dynamic character. What is called static characteristics of instrument? The instruments which are used to measure the quantities which are slowly varying with the time are mostly constant. That is not vary with the time is called as a static characteristics. So there is no change in the time. Mostly is a constant value. That is called static. There is no change in, that is called static characteristics of instrument. These are the static characteristics of instrument: accuracy, precision, sensitivity, resolution, threshold, drift, error, repeatability, reproducibility, dead zone, backlash, true value, hysteresis, linearity, range of span, bias, tolerance, stability. These are the various parameters to measure the static characteristics of the instrument. This is resolution. The definition is smallest input increment change to smaller but different numerical change in the output. Only based on the human nature can. Okay, thank you.